free radicals. Free radicals are neutral species having odd electron. That means they have one unpaired electron, because of which they are paramagnetic. They are neutral species. So in total they have 3 bond pair electrons and 1 unpaired electron. So total they have 7 valence electrons. Alright, they are neutral, so they do not get attracted towards a positive or a negative plate if you apply any electric field. Now let us discuss their stabilities. So what do you think? What will be the stability order? For free radicals, stability could be compared on the basis of resonance or hyperconjugation. So more is number of alpha H, more will be stability. For example, if I compare for that matter, if I have, let's say, this free radical CH3CH2 free radical, then we have CH3CH free radical, then we have tertiary butyl free radical. So over here in these 3 examples you can check out what do we have. Here we have 3 alpha hydrogen, here we have 6 alpha hydrogen, here we have 9 alpha hydrogens. So this one is a tertiary free radical, this is a 3 degree free radical, this one is a 2 degree free radical, this is a primary free radical. 1 degree is also called as primary free radical, 2 degree free radical is called as secondary free radical, and 3 degree free radical is called as tertiary free radical. So the stability order can be compared on the basis of hyperconjugation. So this has 9 alpha hydrogens, so maximum hyperconjugation, this one has 6 and this one has 3. So least hyperconjugation, so least stable. This one has maximum hyperconjugation, so it is most stable. So 3 degree is more stable than 2 degree, 2 degree is more stable than 1 degree, and that has been concluded from hyperconjugation. Alright, next we have that you can calculate number of hyperconjugating structures. From where you will find out that? That is a simple trick, I'll tell you. You just count alpha hydrogens. Alpha hydrogens, the carbon adjacent to free radical carbon is known as alpha carbon, and hydrogen attached to this one are called as alpha hydrogens. So the number of hyperconjugating structures of a free radical is equals to number of alpha H. So this will have 3 hyperconjugating structures, 6 hyperconjugating structures. This one has 9 hyperconjugating structures because number of alpha H is 9. So number of hyperconjugating structures can also be calculated from number of alpha hydrogens. Alright, and in the last example, allyl free radical, you have resonance happening over here. So due to resonance, the stability of allyl free radical is quite stable. Same happens with benzyl free radical, which is also stable due to resonance. So that is it for now. Thank you.